module, right? That is called as the embedded system components. What you have in a embedded system up to now, what you have studied, it's only uh, our microcontroller. that is a that is a building block of every embedded system, right? And that ARM processor is basically the core of any embedded system, which is going to carry out all the arithmetic and logical operations of the embedded system. Now we delve into actual embedded system. What do you mean by embedded system? What are the basic components of the embedded system and all the things, right? That is the whole purpose of the third module. So what is an embedded system is, right? An embedded system is an electronic or electromechanical system designed to perform a specific function and is a combination of both hardware and the firmware, right? We call it as a firmware instead of the software. Unlike your desktop machine or the laptop and all, we call it as a software, right? But on an embedded system, we call it as a firmware. That we have already studied in the class. I have told you that we used to call it as burning. I am flashing it. I am flashing operating system on a mobile device. We say that we are flashing it, but on a desktop machine or on a laptop machine, we call it as I'm installing an operating system. Okay, that is what an embedded system is, an electronic or electromechanical system designed to perform a specific function and is a combination of both hardware as well as the firmware. It is a combination of both hardware and firmware as well. Every everyday system is unique, and the hardware as well as the firmware is highly specialized to the application domain, right? Every embedded system is specific in nature, and both hardware and software has customized, all right, to the application domain. Let us take, for example, you have an called fridge or the refrigerator. To what you have it contains an embedded system, right? And this embedded system, what is that? You have an component and also a firmware, and that firmware is very specifically designed for the refrigerator. I cannot put a firmware meant for a TV on a refrigerator embedded system. We cannot do that, right? And even with respect to the TVs as well, TV is an embedded device or embedded system where it comes with a firmware. What you are doing is that you are flashing that firmware on a chip and placing it into a TV. And this firmware is specifically designed or specifically meant for the TV itself. I cannot take that firmware and install it on a oven, right? I cannot do that, right? Or I cannot install that firmware on a refrigerator. That is not right, right? Every embedded system is unique, and the hardware as well as the firmware is highly specialized to the application domain. And embedded system, what is the difference between an embedded system as well as the general computing system, right? The computing revolution has begun with the general purpose computing environments requirement. Later it was realized that the general computing requirements are not sufficient for the embedded computing requirements, right? So you cannot put all the general purpose requirement for a embedded system. You cannot do that. The requirement of the embedded system is different from the requirement of the general computing systems. That's why what you're doing is that you're segregating it, or you're separating the requirement of the embedded system from the general computing system. The embedded computing environments demand something special in terms of response to stimuli, meeting the computational deadlines, power efficiency, limited memory capability, and etc. Right? So unlike your general computing system where you have huge memory, it is in terms of 8 GB RAM or 500 GB hard disk, and you have all the things, right? And you don't need much stimuli there, right? But in case of the embedded system, you require a very last of uh, features here, something like stimuli, right? One, as in when you press something on the mobile device is also an embedded system, right? So as in when you press a button on the mobile device, it has to open it, right? That is called as a stimuli. Meeting the computational deadlines, it has to handle the multiple applications simultaneously, right? and also power efficiency. That is one important aspect of the embedded system, because almost all the embedded systems are portable in nature, right? So they they don't have infinite power, right? So what you have to do is that within that and the size of the embedded system is also very small one, right? So you cannot put an infinite power into uh, the embedded system. So what you have to do is that the power efficiency is you are looking for a power efficiency in an embedded system, but whereas general computing system you don't look for that, because they are kept in a room which is having 24 bar common power supply. And if the power supply is not there, you are supposed to you have the UPS backup as well, so there is no much question of that. And limited memory capability, that is one more important aspect of the embedded system. You look at any embedded system like something like your mobile device itself, they look for the memory, right? How much size you have it, whether it is 4 GB RAM or 8 GB RAM or 16 GB RAM, and they ask it, right? But on a general computing system, the memory doesn't like, it has a importance, but they don't look for much things, right? If they want, they will put the expansion cards there and they start working on. But on an embedded system, it's very difficult. And look at this, the difference between general purpose computing system as well as the embedded system. A system which is combination of generic hardware and a general purpose operating system for executing variety of applications. You are just having a generic hardware as well as a general purpose operating system. You right? Generic hardware in the sense you can bring an SMS of one system and fit into another system, that is generic one. Or you can bring one GPU, that is a graphics card, and fit into another machine. That's why they call it as a generic hardware. And general purpose operating system in the sense, you have Windows 10, right? You can install this Windows 10 on any machine. You can install it on HP, or you can install it on Dell or any other machines. That's why these are all generic, either the hardware or the operating systems are generic. But whereas embedded system is a combination of special purpose hardware and embedded OS for executing a set of specific set of applications. They are meant for executing specific set of applications, right? And contains general purpose operating system, that you already know that, right? So they are making use of the general purpose operating system in case of the uh, general purpose computing system. uh, it may or may not contain an operating system for functions, right? As far as the mobile devices are considered, they have the uh, operating system, but not all the systems will have the operating systems, right? And applications are alterable by the user. It is possible for the end user to reinstall the operating system and also add or remove user application. The firmware of the embedded system pre-programmed, it is not alterable by the end user. There may be exception of system supporting OS kernel image flashing through special hardware settings. But in case of the general purpose computing system, you can uh, reinstall an operating system, right? A user can reinstall an operating system on his own, but that is not done on the embedded system. A firmware cannot be installed by the end user, right? And performance is key is deciding factor in selection of the system. Like faster is better. You are looking for a system which is having the faster speed, and you're choosing that. Application specific requirement like the performance, power requirements, memory usage are the key deciding factors. In this case, we are looking for something special, right? You are looking for performance. I want to have a system which is giving best performance, or I want to have a system which is having higher power requirements, or the sorry lower power requirements, right? And higher memory, right? Lower memory usage. That is what we are looking at. Less, not at all tailored towards reduced operating system power requirements. Options for different level of power management, like they are not meant for operating system, sorry, operating power requirements, right? So because it is directly connected to the UPS or the power supply, so there is no much question of the reducing the operating power. But here highly tailored to take the advantage of the power saving modes. supported by the hardware and the operating system. You are tailoring, or you are just customizing your embedded system in such way that this is going to meet the power demands, right? And response requirements are not time critical. So you are not looking for the time critical application in case of the general purpose computing systems, right? For certain category of embedded system like the mission critical system, the response time requirements is highly critical. You are looking for something which is highly critical systems. Need not be deterministic in execution behavior. Execution behavior is deterministic for certain types of and embedded system like hard real-time systems, right? So the deterministic or not deterministic may not be deterministic to execution behavior, right? They are not deterministic in execution behavior, whereas they are embedded systems are deterministic. So what is the how the embedded system have evolved? Embedded system were in existence even before the IT revolution, built around the old vacuum tube and the transistor technologies. Advances in right, they are built even before around the vacuum tubes as well as the transistor technologies. Advances in semiconductor and nanotechnology and IT revolution gave way to the development of miniature embedded system, right? Advancement in the semiconductor as well as nanotechnology, they have given an edge in the embedded systems. The first recognized modern embedded system is the Apollo guidance computer, right? Which is one system which is embedded system developed at the uh, by the MIT Instrumentation Laboratory. It has 36,000 words of fixed memory and 2,000 2K volts of erasable memory, right? So this is having 36 kilobytes of words of fixed memory and also 2 kilobytes words of the erasable memory as well. The clock frequency is 1.024 megahertz and it was derived from the 2.048 megahertz crystal clock, right? It has a speed of 1.0424 megahertz. The first mass-produced embedded system was the Atonetic TICS D17 guidance for computer for the uh, Minuteman 1 missile in 1961. That was the first embedded system developed way back in 1961. The first integrated circuit was produced in September 1958, and the computers using them began to appear in 1963. Right, that is what the history of how the embedded systems were classified. Some of the criteria used in the classification of the embedded systems were the embedded systems were classified based on the generation, and they are classified based on the complexity and the performance requirements, and based on the deterministic behavior as well as based on triggering. Right? What is the the type of this one they are deciding. So let us look at how the classification is based on the generation. The first generation, second, third, fourth, and fifth. Next generation embedded system. What is that first generation? Uh, the classification based on like based on the generation. Early embedded system were built around 8-bit microprocessor, right? They were built on around 8-bit microprocessor, simple in hardware circuit with format developed in assembly codes, right? The format was written uh, in a assembly code, that is digital telephone keypads, stepper motor control units, and all the things. It is it is having a 8-bit microprocessor. And the second generation embedded systems built around 16-bit microprocessors and 8-bit or 16-bit microcontrollers, right? They have a combination of these two, that is a microprocessor as well as the 8-bit microcontrollers or the 16-bit microcontrollers. Instruction set were much complex and powerful than the first generation, right? These are having simple hardware circuit they are using it, and also the instruction set were very simple for the first generation. But for the second generation, the instruction set were a little complex compared to the first generation, and also they are more powerful than the first generation. Some of the second generation embedded systems contained embedded operating system for their operation, right? Second generation embedded system contained operating systems to function it. That is the first one, like example as data acquisition systems, SCADA systems, and etc. Right. So the second generation, they are built around 16-bit microprocessor as well as 8-bit or 16-bit microprocessor, and they have relatively complex instruction set as well as they are powerful than the first generation computers or the first generation embedded system. And third generation, the embedded systems built around 32-bit microprocessor and the 16-bit microcontrollers, right? And application and domain-specific microprocessors, controllers like digital signal processor and application-specific integrated circuit came into picture. They have been included in the third generation embedded systems. The instruction set of processors became more complex and powerful, and the concept of instruction pipelining is also evolved. Right? They are using the instruction set becomes more complex, as well as the concept of pipelining also came into third generation embedded system. Dedicated embedded real-time and general purpose operating system entered into the embedded market, right? We have a dedicated embedded real-time and general purpose operating system also came into market. Embedded systems spread in its ground to areas like robotics, media industrial process control and networking as well. So that is what the third generation embedded system. And the fourth generation embedded system is that the advantage system on chips, reconfigurable processors, and multi-core processors are being high performance, tight integration, and miniaturization into the embedded device market. Right? The associate technique implements a total system on a chip by implementing different functionalities with the processor core on an integrated circuit. You are just using an multiple functionalities that is being integrated on a single chip. They make use of high performance real time embedded operating system for their function. They are using high performance operating system to function it properly. Like we have smartphone devices and mobile internet devices which come into existence in the fourth generation. And the next generation, the processor and embedded market is highly dynamic and demanding, right? Next generation. And the next generation embedded system are expected to meet growing demands in the market, right? The processor are running as well as embedded market is also growing in demand, right? So that is what for the today's class. And in the next class, we'll talk about other issues, right?
Okay.
We'll stop it for today, and we will continue in the next class, right?
Yes, sir.
Okay. Wait, I'll take the snap.